Hey, what's up everybody? I got a bunch of shots of the Chicago skyline from across Lake Michigan that support my hypothesis that the Earth is not a ball. We can see too far. Now the news would have you believe that what you are seeing here is a mirage. That the clear image of the Chicago skyline you see from across the lake is actually being lifted 500 feet or so up from behind the curve of the Earth. Disproving this alleged curvature, however, is as simple as taking pictures of the Chicago skyline at increasing distances. You will find that you can see buildings you shouldn't be able to see. News station WMBD-TV won an Emmy because they found this guy to explain how we can see too much of the skyline because cold air is bending light around the curve of the Earth.
One way that can happen is called looming, and this is a situation where cases where you can see objects in the distance that would normally be obscured by the curvature of the Earth. So as an example, in the next picture we'll show a picture taken from a person standing on the shoreline of Lake Michigan, and he can see almost to ground level Chicago, whereas normally you wouldn't be able to see that far because of the curvature of the Earth. So what's happening in this case is, especially this time of year, Lake Michigan is much colder than the air above it, and that has the effect of cooling the air just above the lake. And so now you have the case where the index of refraction is increasing with the height above the lake, and this has the effect of bending light rays back down so that they can get around the curvature of the Earth and be seen by an observer standing on the shoreline here in Michigan.
Well, I took these shots when the air and water were both 34 degrees. And if the news team had gone to the trouble of taking photos from progressively increasing distances as I did, then there would be no doubt that the Chicago skyline as seen from Michigan is not being lifted up from behind the horizon. It's simply failing to disappear as fast as it should if the Earth was a ball. There is indeed atmospheric distortion going on. Check out this side-by-side comparison shot that shows just how much the tower is changing shape as distance increases. In the frame on the left, the top section of the Willis Tower is about 3/4 the size of the section beneath it. From 53 miles away, the top section appears to be about 1/3 of the size as the section beneath it. This distortion of the building shows that there is atmospheric lensing going on. I think Rob Skiba explained this quite well in his video about the Chicago skyline. Differences in air density due to temperature and humidity cause the air to act as a lens, which causes the tops of the buildings to stretch and the bottoms to become obscured. Another atmospheric effect at play when looking out at distant objects near the horizon is indeed the mirage effect. We are all very familiar with this effect. It happens over flat surfaces like roads, and it makes it look like there's water on the road. This mirage effect occurs over the water, and it makes it very difficult to tell what's what when looking out over the water's surface. Check out the curvature test I did in Madison days prior to heading down to Chicago. Here is the target location, a red lifeguard chair and my brother and girlfriend with a bright light. From the other shore 5.7 miles away, there ought to exist 22 feet of curvature drop. Looking out over the ice towards the other side, it seemed very hard to believe that there could be that much curvature. However, when I got to the other side and took a look from ice level, I couldn't find the light in the chair. But while I was searching, I saw a bird land in what I previously thought was the sky. Seeing this made me think twice about just what I was looking at. I got up off the ice 10 feet or so and I saw the light right away with my naked eyes. We found that the light was not visible if either of us was below about 15 feet. It was this experiment that inspired the Chicago experiment. I wanted greater distances and buildings tall enough to get above that shimmering, distorted layer at the water's surface. Here is the view of Chicago from 200 feet high and 53 miles away. Quite similar to the Nowicki photograph. The skyline is the same height, only the shorter buildings are less visible. In my view, this is simply because there's less haze in Nowicki's shot. In addition to the distortion due to refraction in the mirage layer, the mechanics of perspective cause the bottom of the skyline to disappear as distance increases. Any artist drawing in perspective knows that the sky and land or water appear to converge in the distance at the vanishing point. Bumps in the landscape, like hills or waves, rise above the viewer's direct sightline and hide more distant features at lower elevations, meaning that any obstruction in line of sight near the vanishing point will raise the line of sight to above horizontal. This effect appears to cut off bottoms of buildings when viewed from a distance. It does not, however, cut off as much of the buildings as it should if the Earth was a ball. In my research for this project, I came across this video. I want to point out a couple things about this video that I think illustrate the sleight of hand tactics used by those who wish to confirm their existing beliefs, or worse yet, to knowingly lead people towards false conclusions. I went to Long Beach, Indiana, and I got pretty much the same shot as the one in this video. However, the author claims that there are 230 meters of skyline missing, when really there are only 200, as you can see. Also, according to the accepted 8 inches per mile squared curvature formula, there really should be 270 meters of skyline missing. Subtracting standard refraction to arrive at the 230 figure is bogus. But even with the bogus standard refraction, we are still seeing too much of these buildings. The bottom line is that we can see too far. Go to a body of water near you and have a look. Be it islands off the coast or cities across the lake, we can see farther than we should be able to see.